Okay. So JS8Call is actually an application written by a guy called Jordan Shearer, KN4CRD. It's based on the WJSTX code base, and Jordan actually created the JS8 modulation method, or modulation, which is a modified version of FT8. So basically it's FT8 and he just changed it. Now, those of you that don't know how FT8 works, it doesn't send plain text across the air. Well, not just plain text. It actually has a protocol that runs within the mode to do shortened characters, to do special characters and different types of communication. It also has fixed format sizes. JS8 takes FT8 and extends that so that it can do real-time keyboard, as well as store and forward messaging and automatic station announcements. So the application runs on Windows, Linux, and Mac OS. I'm running it on a Mac OS M1 Mac, a MacBook Pro. At the moment, it runs fine, even though it's a x86 application. It seems to be running beautifully, actually. Like I said, it uses a modified version of FT8. It's called JS8 for Jordan Shearer. Like FT8, it's designed for weak signal communications. In the slow mode, it can go down to about minus 28 dB, well into the noise floor. Makes it very hard to see. So it is designed for weak signal communication, like FT8. Like FT8, it has a checksum and lots of redundancy built into the signal, which is how it can get down to such low signal levels. On air, an individual JS8 call or JS8 signal consumes about 50 hertz of bandwidth in normal mode. If you go to slow mode, it halves that to 25 hertz. If you go to fast mode, it actually goes up to 80 hertz. The difference between slow, normal, and fast we'll get to in a minute. It's an 8-tone continuous phase FSK signal. So what that means is that it actually is always got a tone transmitting. So if it didn't have any breaks or anything in it, it'd be 100% duty cycle, much like RTTY or PSK. Actually, no, PSK isn't, is it? So it's much like RTTY, or MFSK. It's a 100% duty cycle, except the protocol itself has breaks within it, small gaps. It only transmits for a short time, about 15 seconds, and then it breaks, and then it transmits again. So in that time, a normal transmission is typically about 84% duty cycle. Actually, that's on the next page, so I'll go there. So if you look here at the modulation modes, we've got 4 speeds. As you can see, they equate to roughly X many baud. A baud is bits per second. In this case, I think I've got a better listing on the next on one of the next slides about how that equates to words per minute. So we'll wait until we go there. If you know anything about MFSK or FT8, you'll see this is pretty much bog standard. It's just an 8-tone continuous phase signal. Here we are. So each of the individual modes has a frame time. The slow mode takes 30 seconds to send a frame. A normal takes 15 seconds to send a frame. The fast takes 10 seconds. And the turbo 6 seconds. Bandwidths go up, of course, as the speed goes up. So a normal mode gives you about 16 words per minute. A fast, so the two you'll probably use the most are normal and fast, and a fast is about 24 words per minute. Now, the faster the mode, the better the words per minute, but the more signals you need to decode. Fast mode, for instance, will decode down to about minus 20 dB. Normal down to minus 24. I was decoding and chatting to people at minus 19 today, so that's quite useful. Here we are. So the frame's 12.6 seconds, but the actual window that it transmits is 15 seconds. So for a normal frame, the transmit cycle is 84%. And actually, after the window, it dekeys and then rekeys. As you go faster and faster, the duty cycle does come down a little bit because there's more gaps than there are transmitted frames. But for the most part, consider it about 84% to 100%. So treat your radio nicely, guys, and don't overdrive it and run it flat out. So JS8Call is USB on all bands. None of this lower sideband below 20 meters bullcrap. It's USB on all bands. Now, timing synchronization is very important. Having the clock right on your computer is vital for a lot of these modes. FT8 included, WSPR, and JS8 as well. And the reason for that is they need to synchronize the frames up. So you need to synchronize within about 1 or 2 seconds so that you're transmitting when people are expecting you to receive, and so on and so forth. It makes decoding the frames a lot easier because you know roughly when they start and when they stop. So if you don't have your computer synced to an internet time server or manually set the time, I don't know, I think that I'm not even sure the talking clock exists anymore, but you can certainly get the time off the net very quickly, or listen to WWV if you can hear it. I run time server syncs here internally in the house, and the computer's all synchronized back through the internet. So I think I'm within about 20 milliseconds or so of network time. The other thing to remember is audio levels are very important. This is one mode that is very, very unforgiving if you overdrive your radio. If your radio has the ability to measure ALC, you're able to see your ALC as you put signal into your radio, you want to really just pip the ALC so it's just starting to move, and that'll give you a good signal. For those of you with 100-watt radios, you're probably looking at about, I don't know, 30 watts, 25 watts. And that's, you don't want to go anywhere above that. Otherwise, it'll cause issues. Any sort of distortion on the output signal makes your signal very hard to decode. And on receive, turn off AGC or set it to fast. You don't want it varying the levels of your signal that much. So those of you that have modern rigs that can interface via CAT or similar, JS8Call will talk to HamLib or FL Rig. I didn't have much success making it talk to FL Rig, but I use HamLib and it seems to work very well. You don't actually need CAT control. You do need some way of transmitting or keying the radio up while you feed it audio, but you can do anything from run a script to do that if you have a way of doing that via a script, to using HamLib to directly controlling it via a serial port or a parallel port. All of those features are available in the actual software itself. Vox may also work, but you really have to have the Vox set to a hair trigger. And again, as I say, the audio levels are where you're going to have problems. It's where you're going to go wrong. So this isn't like RTTY or PSK. It's more like FT8, where there are a set of defined message types. In JS8, there are actually 3 types of messages. There are standard free text messages, similar to what you do with, say, RTTY or PSK, where you can just type it in and send it. Now, the people who will receive that are only the people who are listening on the frequency that you're transmitting, on the exact frequency. So that little 50 hertz, so they're netted to you directly. That's fine if you've got someone you're talking to and you netted to them directly, you can just have a chat using that. The second type is called a directed message. As part of the protocol, it includes the ability to click on someone's name if you've heard them, or type their name in, and it will direct the message to them. Now, when JS8 looks at the spectrum in front of you, it actually decodes the whole spectrum at once, from about 600 hertz right up to about 2.3 kilohertz. And it's looking for multiple 50 hertz, or, depending on the speed, signals, and it'll decode all of them. If they're all firing off at once, it'll grab them all. And then it'll decode the protocol inside the modulation. And then it'll look for your call sign. If your call sign is there, or one of the groups are there, which we'll talk about later, then it will show it to you in the center screen. Again, we'll show that to you. It'll highlight to you that it is a directed message meant for you. In this way, you can have a directed chat with two of you that aren't netted on the same frequency. And it's just not an issue. I was chatting with a VK5 this afternoon, and we were, a kilohertz apart in transmitted frequencies, but the JS8Call just did all the work. I didn't have to worry about netting it. I just included his call sign. I clicked on his call sign, and JS8Call did the rest. And the last one is group messages. Group messages are like call signs, but you can tell JS8Call to listen to a particular let of groups. By default, one group at all call is available immediately, or by default. And with group messages, you can send messages to a group of people. So, for instance, if we wanted to tonight, we could put an @CRARC as a group call. And then if anybody sent a message with a group distribution of @CRARC, then we'd all see it, anybody who was listening to that group call. So, yes, you can spam the world. So, let's now have a quick look at the application. So, here is the main screen. This is the JS8Call program. Top left, we have the frequency. If you have cat control, you can change this frequency and it will change the frequency of your radio. This little number here is the frequency at which the offset is, or this little frequency is down here. So the frequency you are transmitting on and receiving for undirected messages. Here is your call sign and some date and time information. Over here, we have some buttons that are also indicators. This says whether you're enabled or disabled the receiver. So at the moment, my receiver is enabled. My transmitter is enabled. I can click it and turn it off. And now, no matter what button I push, the system won't transmit. This here is the spot. It spots to reporting networks. So PSK reporter and a couple of others, I think. And here is a logging tool. I haven't played with the logging tool much, but you can insert an entry into the log, and that'll actually save that information for you. And you can look at the log in the log directory later on. I'm pretty sure it just puts it into a text file. This button over here to the right is the tune button. That'll actually send a signal to your radio so you can tune your radio up or tune your ATU. And the button above it does a fair bit more work. If you click on that, it actually gives you the modes to use, how sensitive the decoder is going to be, and enables simultaneous decoding of all speeds. Now, unless you have a very slow computer, I would leave that on or make sure that's set on. In this case, it's set on, so it doesn't matter which speed people are using. In fact, if you look here, there's a normal, there's a fast, there's a slow, normal, fast, fast. So these are the modes for people that have been transmitting, and the system will decode all of them simultaneously. So you don't have to worry about if anybody is running fast or slow or whatever. They will, you'll see them. The other options in here were actually enable auto replies. So you can actually send queries to people like, what's my signal to noise ratio? What's your info? You can also enable heartbeat networking, which I'll come to in a minute. The left-hand window here is actually showing the activity on the frequency. So anything that is decoded. So if you've got multi turned on, all speeds, but also everything across the entire frequency from 500 hertz up to 3 kilohertz will be decoded up here, and it'll tell you where it decoded it up here. The window in the middle is your received window. So what appears in there is transmissions that were on the frequency you are tuned to, where the red bars are down below. Also, any transmissions that have your call sign in them, or the group call. In this case, add all call is the only group call I have. The box below it is where you type your outgoing free text, or any text, in fact. That is actually where it's going. And on the right-hand side is everybody you've heard and how long ago it is since you've heard them. For instance, I heard VK1MF 2 hours ago. I heard Rob 1 minute ago, and he was minus 11 dB. And he was on 706 hertz. Now, anything below 1 kilohertz is typically a heartbeat. So, although it looks like Matt and Wade were just chatting and 700 hertz. So I'm not sure if that's... Anyway. Now, this row here is a set of shortcut buttons or macro buttons. Because I've got VK2HR selected here, I can click on this directed to and set up and ask him any of these questions. So I can send a directed message to his call sign, which is what's there, or I can send a reply, send his signal report, or I can even ask him what's my signal report. So if I do that, this comes up here. It's ready to send. It's waiting for the time period to end. And now it's transmitting. So I'm now transmitting. I'm not entirely sure what I'm transmitting on. No, 1500. So it's sending Rob a question for the signal report. And hopefully he will go, oh, yes, Carl, you can have that, and send it back to me. But he may not. Yep, there it is. So this little, you can see this little signal here was him. That was -7, and I decoded him at -19. So I find that massively impressive, actually, personally. And there's a whole pile of buttons here. This is a heartbeat. Now, part of the protocol is a heartbeat protocol where you can have a periodic heartbeat sent out, which people will then respond if they can hear you. So if I set a heartbeat out now, it'll send it out down there at whatever that is, 650 hertz. It's currently sending it. Well, now it's sending it. So it's sending the heartbeat out, and anybody with an auto response or anybody who says, yes, I want to send a reply, will transmit back to me and tell me, yes, I heard you, and here is your signal to noise ratio. So it's gone back to my normal offset of 1500 hertz. And now I wait to see the replies flood in. So one DSH heard me at -11. Somebody else is there at 2000. Who's that? VK5CZ is talking to KJ4YBS. There we go, at -6. Only Dale heard me? Well, Rob's already heard me. Interesting. HP mode is good for when you have no AP connection, RF only. Okay. So that is the heartbeat mode, and that's actually quite useful. You can use that to see if anybody's there and who they're listening to. Now, there is actually a mailbox system connected to this. Now, I haven't played with this, and I'm sure Wade at some point can talk about it. And I'm not going to go into it now, but you can actually leave mail messages, if you like, for other people. Oh, someone just sent a heartbeat request. VK2 NAD sent a heartbeat request. And I'm replying to him now. So you can send messages and have them stored somewhere else, and then you can query that other location. And you can repeat messages through other stations. There's a retransmit facility, all done via directed messages and what you type in here. So you can actually use other stations as a relay, if they've allowed it, to get your messages through to someone. That's an interesting mode for things like Weiston, I think. And it might actually be a very good way of doing that. So down the bottom, we have the waterfall. Actually, On the left-hand side here, sorry, we'll start there. We have the received signal strength. Now, I'm having some troubles at my end with making the signal strength low enough out of the radio to get into my computer. So that's why it's a bit high. Typically, you want to run at about 40 to 50, no higher than 60. But if it's green, it's good. It also says that I'm using cat control. And it's green because it hasn't been any cat control failures. Here is the waterfall. You can see on the waterfall where there's signals or not. On the right-hand side here, you can see various control options. The first one is the control of where I'm transmitting or receiving. The offset here, the center of the passband here. You can also enable some filtering if required. The next one is the display. Now, if you're going to be doing a display, you'll find the initial times when you start this up, it's only looking at like a kilohertz of the band. You can actually change the bins per pixel here to shrink down to see more of the bandwidth, more of the band pass, or whatever. You can adjust where this starts. So that's at 500 hertz. That's at 400, and you can adjust this to where you want to see it, so you can see all of the frequencies. You can also adjust the palette if you like different colors. Ooh. I run it as default because I think it looks nice. There's also a lot more features here for controlling the display. Oh, that's not what I wanted. There we go. So be careful of scrolling. And the last one's timing. This is where if your clock is off and you don't want to reset it, you can adjust for clock drift here. And you can actually, if you're seeing a lot of stations in the being decoded, you can actually do an automatic time drift decode here. It'll actually look for another station or other stations and work out where your clock is in regards to them, and decode it. And then it would automatically set up a time drift here, so you can do it. You can also set the time drift there if you need be.